So in this question refers to the previous question as well. We want to know what happens, what is the speed of the center of the mass immediately before the collision? Well, so the center of mass of this object after the collision, what we know is that we have this new particle that has a center of mass somewhere here, like so. And that mass, that entire system is located at the center of mass, is moving with a velocity vs. Now, if the center of the mass beforehand, when there were two particles, were moving at something different than vs, then we would have a different momentum of the system before the collision than after. Because the momentum of the system must remain constant. The initial momentum must equal the final momentum. If the momentum afterward is moving with a certain velocity vs, that combined particle, well, it must have the same vs beforehand. Whether or not both particles are moving with the same velocity v, whether one is stationary and moving toward v, or moving at a velocity v, or whether one is moving this way and this one is moving this way. It's the center of mass of the system, that velocity, reducing the entire particles, all the particles in the system, to one center of mass. It's that momentum of the center of mass that's conserved. So, for the law of conservation of momentum to hold, the momentum of the system before must be equal to the momentum of the system afterward. And there is a mass of the system before and a mass of the system afterward. And so those two masses must be equal to each other. The system isn't changing. So therefore, the velocity of the systems must be the same as well.